For the horsepower lab, we need to calculate how much power we have, assuming we climb the stairs. And I use the stairs that we have at school, and they should all be within the few centimeters of each other. And so I picked the set of stairs that out by my room, 25 steps and 17.5 centimeters high. So if we're going to calculate our vertical distance, there are 25 steps and they're 17.5 centimeters high. So first off, I have to figure out my total vertical distance. So I need to take 25 steps times 17.5 centimeters. And I'm going to need a calculator for this. So that tells me I did 437.5 centimeters. That was my vertical distance. And then with this, we need our distance to be in meters. That's typically what we're using when we're working with our various equations. If I look right here, distance is in meters, so I can't leave this in centimeters. I have to switch that into meters. And so I've got, we've done numerous conversions. I'll set up my fractions, and it says there's 100 centimeters in 1 meter. And those of you that are quick mathematicians doing this with that calculator, that tells me 4.375 meters was my vertical distance. And so now I can take that and transfer that to my distance. And so now I've got that taken care of. I need to keep working because ultimately I want to figure out how much power I had, and then I want to convert that into a horsepower and see how I compared to a horse. And we'll just have to do a series of calculations to get that figured out. And down here, this tells us in terms of what we're doing. Enter approximate name and weight. I already did that for my sample. I've got Mr. K up there, and I'm about 215 pounds. But we can't use pounds, we've got to get that into kilograms. And so number 2, converting pounds into kilograms. So I'm going to take my weight, and I'm going to set up my fractions. And it says there's 2.2 pounds in 1 kilogram. So I multiply straight across like I normally do. And then I go over to my calculator. And I see that I've got a number with a big repeating decimal, 97.72. That means I'm going to go 73 kilograms. So I've got that part taken care of. And I'll leave the number in my calculator because we're going to keep using that number. So don't clear out that big long number. So my mass. So I've got that one. Number 3, to find your force, the weight, we're going to use acceleration due to gravity, which we know that it's 9.8. And then to find our weight, we take F equals ma. Since we're looking at the vertical distance, and I can take my number 97.73 kilograms. A, since we're going vertically. And now here in terms of showing work, all we're doing is using this equation. Well, I already have mass over there. So I've got 97.73. Oops, I got to label that, I suppose. So I just have to take that number times 9.8. So I can just go over to my calculator, hit the multiply button, times, and I'm just going to say 9.8. And again, I've got a number over here. Again, it's a big long number with a repeating decimal, but I'll round that. And that's kilograms times meters per second squared, or that's a Newton, as we know. So I'm going to take that number, and that's what I'm going to put up in my table. That's my weight in newtons. So force in newtons. Okay, and so now I know my force. So I started with my weight, about 250 pounds. I turned that into kilograms, which is about 97, and I took that times acceleration due to gravity, and now I know my force in newtons, 957.72 newtons. Next up, calculate the work that we did. So I'll look at number 4. And as we're going with this video, you guys, you pause as often as you need to. So work is this. Force, I just calculated that, 957.73 newtons. Distance is right here. We already calculated that, so I'll just take that number and borrow that. And I gotta look to make sure I got that right. Yeah, there we go. All right, so if you look over there again, I already have that number. It's still in my calculator, and I just need to multiply that with my force equation. So force times distance. So I'll just multiply by, what did we say, 4.375. So there's my work. Again, big repeating decimal, but we'll clean that up. 0, that would be, I'd round up 0.05, means mine becomes, oops, not a 0.07, 0.06, and that would be Newton times a meter, or I'll use the other label, joules. And so that's how much work I did. So when I went up the stairs and timed myself, that's how much work I did. So I'm gonna come up here. Okay. And my time going up the stairs, I didn't exactly sprint up the stairs, but I wasn't going slow either. 9.98 seconds was mine. So I now know my work. Make that a nicer looking 0. And now we calculate power. Calculate power in terms of watts is where we're going. So power, work, I already just calculated that, 4190.06 joules. And my time was 9.98 seconds. I gotta make sure I got that right. Yep, 9.98 seconds, so I took the correct time. And now, there's my work, times 9.98 joules again. That's sitting over there in the calculator. And so all I need to do is go times the time, which in this case was 9.98. Oh. I did that wrong, you guys. Divided by 9.98. So this one, let me fix this. There we go, that's back to, so there's my 4,190. I've got to divide this by 9.98. There we go. And that equals 419.84 watts. First off, sorry, that would be joules per second, or 419.84 watts. Either one of those is correct, so I'm going to go up to my table. Watts. And so that's what I had going up the stairs. And now my last one, I just want to convert that into horsepower. And so I'm going to take that 419. So I have 419.84 watts over 1. And 746 watts is equal to 1 horsepower. Multiply straight across like we normally do. Oops, I don't want to do there, I want. And again, my number, it's right over there in the calculator. You see it on my calculator. So I'm just going to divide that by 746. And my horsepower was about, I was about 0.56 horsepower. That's about half of a horse. So based on James Watt's calculations, when I went up the stairs, I was doing the work of about, or had the power of about half of a horse. All right, so you've got the video shows how to go through all of the steps. You have the sample for each one of those problems as we go across. I showed you how to go from, again, I started at my weight, and then we just worked all the way across from mass to force to distance, work. We had our time, and we ended up with the horsepower. And so what I'd like you to do is calculate for the sample students, students 1, 2, 3, and 4. Just like the previous one we did, I don't need to see all of the work, you guys. You've got that there. Plug those numbers into your calculator. Just work across the table, fill in that table, and see what happens with their work and their power. Ultimately, that's what I'd like you to see. And then, of course, when you're all done, answer the questions.